Hello everyone. So today we will cover the learning outcome 5 for introduction to statistics, and today we will cover to understand the use of probability distributions. So in this session, just a second, I will drag this. In this session, the indicative content that we will cover include what probability distribution means and what are the different types of probability distributions, the uses of binomial distribution, for example, for economic predictions, the modeling assumptions in binomial distribution, and how to calculate binomial probabilities using a calculator. Next one is like properties of normal distribution, the uses of normal distribution, application, and when it can be used to approximate binomial distribution and the interpretation of the results. So first of all, we go into the key terminologies. So first thing is like what is probability distribution? So a probability distribution, it generally represents like it is a mathematical function which provides the probabilities of various potential outcomes for a given experiment. So this function serves as the mathematical representation of a random phenomenon, describing it in terms of sample space and likelihood of specific events occurring. So basically, it is the likelihood of the events occurring. So in practical terms, it helps us to understand the likelihood of different outcomes, like I said. So it can be categorized into different types, which includes normal distribution, binomial distribution, and Poisson's distribution. So each of these probability distributions, they have their own characteristics and applications. Although when a person they want to use the probability distribution, they would have to assess the scenario and which probability distribution is most suitable to be used in that scenario. So for example, the normal distribution, it is also called as a bell curve. So bell curve is very common used in applications in industry. For example, it is used for appraisal rating of individuals. It is used for basically the performance of individual. It is used for heights. It in academics, it is used for the test scores. So that is the use of normal distribution. Uh, the binomial distribution, it is used to analyze the probability of success or failure. So it is generally yes or no, or binomial means which reveals the outcome of either of the two outcomes in a scenario. So the probability distributions, they are fundamental in statistical analysis, and it is also important to note that they are used by researchers and analysts to make informed decisions based on the probability associated with each scenario. For example, the different outcomes it could be, and it is used in a wide range of sectors. It is used in sciences. It is used in different business applications. It is used in economics. It is used, for example, weather predictions. So it has it is a very useful concept which is applied generally. So now the first one we start with is what are the general properties of probability distributions? The probability distributions are fundamental concepts in statistics and probability theory. So they describe how the probabilities of different outcomes are distributed in a random experiment or process. So the general properties of probability distributions may include a range of possible values, which, for example, a test score could be like from 0 to 100. So it specifies the range of all possible values. So these values can be discrete, separate, and countable, or continuous, infinite, and uncountable. So, for example, your test scores, if it is in whole integers, it could be 1, 2, 3, 4, or if it is in fractions, also it could be 17.5 or 14.5, something like that. So next, we have probability density function or probability mass function. So it assigns the probabilities. For example, the probabilities, as we have studied in the previous sessions, it could range between 0 and 1. So the PDF or PMF, it assigns probabilities to each possible value in the distribution. In the case of a discrete distribution, it provides the probability of each discrete outcome. So for continuous distributions, the PDF defines the relative likelihood of different intervals or ranges of values. So it is basically associated with the concept of the likelihood of different intervals. So, for example, what is the likelihood of the entire class scoring between 40 and 70? So that is used, that is calculated using the probability density function or probability mass function. So next we look into the probability summation or integration. So the sum for discrete distributions or integral of probability over all possible values is equal to 1. So, your probability cannot vary. It cannot be less than 0 or it cannot be greater than 1. So the sum for all probabilities, it has to be 1. So this property ensures that the distribution accounts for all possible outcomes. So this is a theoretical concept. Then expectation. So the expectation or mean of probability distribution represents the weighted average of all possible values, with each value weighted by its probability. So it is a measure of central tendency. So the expectation is the weighted average by divided by it represents the weighted average of all possible values, with each value weighted by its probability. For example, if if the weighted average is 0.7 and the probability is 0.2, so your expectation is 0.7 into 0.2. Then you have variance and standard deviation. So this is a very common concept in mathematics as well as statistics. So variance, it represents the spread or dispersion of values from the mean value. For example, if your mean value in a score of 0 to 10 is 6 and your variance is 5, that means you are very much differing from the mean. For example, if you have got 1 and the mean value is 6, that means the variance is very high. So it indicates how much individual values deviate from the mean. So that is the interpretation of variance. And standard deviation is the square root of variance and provides a more interpretable measure of spread. So both of these parameters, they represent the dispersion from the mean. So this is again used in probability distributions. Next is skewness. So skewness, it measures the asymmetry of the distribution, which is, it could be longer tail, it could be shorter tail. So positive skewness, it indicates a longer tail on the right side of the distribution, while negative skewness indicates a longer tail on the left side. So again, it is used to indicate the characteristics of the sample or the population. So kurtosis is another statistical concept which measures the tail enders of the distribution. So high kurtosis indicates heavy tails and more extreme values. For example, in a score of 1 to 10, somebody may have got 9.5, but the average is say 4.5. So 9.5 value represents a very high kurtosis, while low kurtosis indicates lighter tails and fewer extreme values. So that is the concept of kurtosis in statistics. Then you have moment generating function. So this is used to derive moments of a distribution. For example, it provides a way to calculate moments beyond the mean and variance. So it is a third statistical parameter which is used to measure the dispersion. Then you have the cumulative distribution function. So the cumulative distribution functions give the probability that the random variable takes a value less than or equal to specific value. So it basically provides a cumulative view of the distribution. So for example, what is the probability that a particular student will get less than the mean value in a class? For example, a student name is say Mark. So, and if the mean value of the class is 4.5, so what is the probability that Mark will get less than 4.5 in his test score. So it provides a cumulative view of the distribution. Then we have characteristics of specific distribution. So different probability distributions have unique characteristics. So here we look into common distributions. Common characteristics of specific distributions are, say, mm, normal distribution, binomial distribution, Poisson distribution, exponential distribution, and many others. With many others, each with its own set of properties and applications. So these are the different types of probability distributions. Then you have the shape. So the shape of the probability distribution can vary widely. Some distributions may be symmetric, like the normal distributions, while others are skewed or exhibit different shapes. So then we have applications. So what is the applications of probability distributions? Probability distributions are used to model and analyze real world phenomena. For example, normal distribution is used to assess the test scores. Then you can have cumulative distribution function. Like I said, it is used to find out the what is the probability that a specific person will get the score less than specific value. So, like I said, the normal distribution is commonly used to describe the distribution of many natural variables, while the binomial distribution is used for binary outcome. It can be yes, no, it could be success or failure. It for a roll of for a toss of coin, it could be heads or tails. So that's where binomial distribution is used. Then we have transformation. Probability distributions can be transformed to create new distributions. For example, the sum of independent random variables often follows a different distribution than the individual variables. So that is how you can use the transformation of a probability distribution to new distribution. So next we look into explaining when the binomial distribution may be appropriate in real world situations. So, binomial distribution is appropriate in real world situations when the following conditions are met. So, what are those conditions? The first condition is binary outcome. So, always remember binomial distribution is always used for binary outcome. So, the outcome of each trial or observation must be binary, meaning it can have only two possible outcomes, often referred to as success or failure. So these outcomes are mutually exclusive and every trial results in one of these two outcomes. Then you have fixed number of trials. So there must be a fixed and predetermined number of trials. For example, if you're tossing a coin, so it's not like you're going to toss a coin indefinitely. It could be a fixed number like 10, 20, 25, 50, 60, 100, 500, whatever, but it should be a fixed number. So in other words, you should know in advance how many times the experiment or process will be repeated. Then we have the independence. So each trial must be independent of others. For example, when you toss a coin and you get heads or tails, first time. The second time should be independent. It should not be dependent that if you have got a tail first time, then the outcome of the second trial is influenced by the outcome of the first trial. So this condition is often met when sampling with replacement or when the population is large enough that sampling without replacement approximates independence. So basically, it essentially calls for independence of the different trials. So the next one is constant probability of success. So probability of success remains constant from trial to trial. In other words, the likelihood of success is same in each trial. So in binomial distribution, it is probability of success of either heads or tail is 0.5, which is same for each trial. So real world situations, what we look into is which satisfy the conditions for binomial distribution are like coin flips, like what the most easiest example which I was giving. So coin flips, it is basically outcome, the heads or tails on each flip, a predetermined number of coin flips, and the constant probability of success, which is like 0.5 for a fair coin. Then we have the product defects. A product is defective, success, or non-defective. So that is again a binomial distribution. So a fixed number of trials could be like say 100 units. Each product's defect status is independent of others. So and constant probability of success. So here you have to define the probability of success in a product trial. For example, probability of defect is probability of success is 95% or the probability of defect is 5%. Then we have the survey responses. So respondents, they agree or disagree with a statement. So again, the characteristic of fixed number of trials need to be assessed. So for example, the survey size is the sample size is 500. Then you have the independence. So each respondent's response is independent of others. And then you have a constant probability of success. For example, you have a 30% disagreement rate, you have a 70% agreement rate. So the probability of agreeing with the statement remains constant. Although survey responses may not be strictly considered as binomial distribution, but still it can be considered as an example. So next we look into how to calculate binomial probabilities. So, calculating binomial probabilities involves determining the probability of a specific number of successes in a fixed number of independent binary trials, which can be success or failure with a constant probability of success on each trial. So, to calculate binomial probabilities, you can follow these steps. Number one step is define the parameter. The first parameter is number of trials. So, you should determine the fixed number of trials or observations in your experiment or process. So you want to see like what is the sample size when you're conducting a survey, or how many coin flips you want, or how many products that you are going to test for the defect. So that is the number of trials that you need to get it fixed. Then you have probability of success. So you have to identify the constant probability of success on each trial. For a coin flip, it is straightforward, it is 0.5. Then number of successes. Decide on the number of successes you want to calculate the probability for. So we look into how we calculate it. So the probability of exactly X successes in N trials. So with the probability of success P, it is given by the binomial probability formula of Px is equal to small x, where small x is the probability of exact successes, xn into px into 1 minus p n minus x. So here px is equal to x is equal to the probability of x successes. Xn, it represents the binomial coefficient which is calculated as the factorial of n into factorial of n minus x into factorial of x. So that is the denotation in mathematical representation. P is the probability of success on a single trial, and X is the specific number of successes you want to calculate the probability for. N is the most simplest thing, which is the total number of trials. So when you plug in the values of N, P, and X, you get the value of the probability of success. So remember here uh, P is varies between 0 and 1. So P plus 1 minus P, it should be 1. So when calculating the probability using the formula, make sure to raise P to the power of X and 1 minus P to the power of N minus X and multiply by the binomial coefficient Xn. So that is a fixed mathematical formula. You just need to plug in the values of different parameters and then you will get the answer for the probability. So interpreting the result So you interpret the result by understanding like what is the probability of obtaining exactly x small x successes in n trials, and with a probability of success p on each trial. So this is how the output of this formula is interpreted. So the next one is explain the use of normal distribution. So we have studied binomial distribution, we have studied different types of probability distribution. Now we look into normal distribution. So the normal distribution is also known as Gaussian distribution or a bell curve. So bell curve is more of the commonly used parameter. So it is a fundamental probability distribution with several important applications in statistics, science, and various fields. It is characterized by its symmetrical bell-shaped curve and is defined by two parameters, the mean and the standard deviation. So some of the examples, real world examples of normal distribution is modeling real world data. So normal distribution is often used to model and describe the distribution of continuous random variables. So some of the commonly used terms in real world could be heights of individuals. So that could be a normal distribution, the weights, the IQ level, then you have the exam scores. So all of these generally they follow a normal distribution. Then you have the central limit theorem. So the central limit theorem states that the distribution of the sample means of a large number of independent, identically distributed random samples approaches a normal distribution, which means that even if the original variables are not normally distributed. So this property is fundamental in statistical inference, hypothetical testing, and confidence level interval estimation. So what it means that even though the independent variables in a distribution may not follow normal distributions, the entire distribution of a sample they will follow a normal distribution. Then we have the statistical inference. So in hypothesis testing and confidence interval estimation, the normal distribution is a commonly used for its known properties. So parameters like mean and standard deviation are estimated using the concept of normal distribution. Then you have the Z scores and standardization. So the Z scores are calculated using the normal distribution and are used to standardize data by transforming it into units of standard deviations from the mean. So this allows for comparisons between data points from different normal distributions. Then we have quality control and process monitoring. So the application is uh, in quality control of manufacturing, the normal distribution is used to analyze process data and control charts. So there are different types of control chart. It could be P chart, it could be C control chart. So that also you can study if you want to get in-depth knowledge with respect to quality control and process monitoring. And then deviations from normality may indicate problems or variations in the production process. So this is how normal distribution is used in the quality control and process monitoring. Then you have risk management and finance. So in finance, returns are always assumed to follow normal distribution. So this assumption is used in portfolio optimization and use of derivatives such as option pricing models. And you have population studies. So in epidemiology and population studies, the normal distribution is used for calculating characteristics such as blood pressure or cholesterol level or heart rates and birth weights. So it helps in identifying outliers and define reference ranges for healthy population. For example, if your hemoglobin level, the general range is like 10 to 14. So whenever if you've done a blood test at any point of time, you'll see that a reference range is given. So that is where the use of normal distribution comes into picture in healthcare. Then you have psychometrics and education. So in application, IQ scores, standardized test scores, and aptitude test scores are often assumed to follow a normal distribution. So example, so a reference range is given like an IQ level above so and so is considered, a person is considered genius or a person is considered average. So this assumption, it gives the interpretation of individual performance. Then random sampling and probability density function. So the normal distribution has a well-defined probability density function which allows for calculating probabilities associated with specific intervals. For example, again, like what is the score of Mark? What is the probability that Mark will score between 4 and 8 in a highest score of 10 in any subject? So that is what is used for random sampling and probability density function. Then you have approximations for other distributions. The normal distribution is often used as an approximation for other distributions in situations where data follows a distribution that is not easy to work with mathematically. So an approximation is used for normal distribution. For example, if the sample does not follow a normal distribution, a logarithmic transformation is done so as to bring it to normal distribution and then perform the statistical tests. So in summary, normal distribution is a versatile and widely used probability distribution in various fields due to its mathematical properties, symmetry, and applicability to modeling real world data. So normal distribution is a very important concept, and you can read more into it to understand the concept, like where it is used, and essentially what is its interpretation in the real world scenario. So next we look into how normal distribution can be applied in real world situations. So we've already looked into a few examples. The first one is like heights of individuals. So the height of individuals in a population always often follow a normal distribution. For example, if you want to study the height of adult males in a city, you can use the normal distribution to estimate the proportion of males with heights within a certain range. For example, a range between 5 feet 8 inches and 6 feet 2 inches. So you'll again see a bell curve will appear when you draw the normal distribution. Then, like we also discussed earlier, the IQ scores, for example, with a mean of 100 and a standard deviation of 50. So, when you're assessing the student's performance on IQ score, you can use the normal distribution to determine the student's percentile rank. So, then again, exam scores. So, you can use the normal distribution to grade the students. For example, you can give the grades A, B, or C based on the normal distribution. Then next you have the measurement errors. So application. So measurement errors in scientific experiments, they also have a normal distribution. For example, in a chemistry experiment, you can use the normal distribution to estimate the range of possible values for a measured quantity and calculate confidence intervals. So this is an application in the measurement errors. Then you have the stock returns. So daily or monthly stock returns, they often follow a measurement normal distribution where the value often returns to its mean. So when assessing the risk associated with a stock portfolio, you can use the normal distribution to calculate the probability of experiencing certain gains or losses within the specific time frame. Then the next example we have quality control. So again, the probability of a defect in a certain of the number of products in a batch. So that again you can assess using the normal distribution, and then you can define the defect percentage. Then you have the blood pressure readings for a healthy population. They often follow a normal distribution So when diagnosing a patient's blood pressure, you can use a normal distribution to assess whether the reading is within a healthy range for the patient's age and gender. So most of the healthcare applications you would see that they follow a normal distribution. For example, if your age between say 21 to 30, then you would have a certain level of you should have a certain range of weight, you should have a certain blood pressure level. So all of these are done based on like lots and lots of trials, and then the reference values have been established. Then you have the process control. So in industries such as chemical engineering and electronics, they rely on normal distribution to monitor and maintain the quality of product. For example, in semiconductor manufacturing, the thickness of silicon wafers is monitored using control charts based on normal distribution to detect deviations from the desired specifications. Then you have the financial risk assessment. So financial analysts use the normal distribution to model asset returns and the portfolio risk of the asset. So here again, the normal distribution is used to assess the expected returns, the standard deviation, and the risk reward trade-offs for the portfolio. So next, we look into the merit criteria for this assignment, which is to compare the properties of the binomial and probability distribution. So binomial distribution and the binomial and normal distribution. So the binomial distribution, like you already said, it is used to predict a binary outcome, either success or failure, yes or no, that kind of outcome. Whereas the normal distribution, it is used to model continuous data. So, so the differences between these two distributions is classified into certain characteristics. The first of which is the nature of data. So the binomial distribution is used to model discrete data that involves a fixed number of independent trials. Like I said, you have to toss a coin or flip a coin 20 times. You know the probability of each either heads or tails, basically success or failure. Whereas in normal distribution, this is used to model continuous data such as measurements or observations that can take any real value within a range. Then you have the shape of the curve of the distribution basically. So the binomial distribution is typically right skewed for small values of n, but approaches a symmetric bell-shaped curve as n increases, or n is the sample size. Whereas the normal distribution is a symmetric and bell-shaped curve with tails extending infinitely in both directions. Then you have the parameters. So in a binomial distribution, it is defined by two parameters, that is number of trials and the probability of success on each trial. So these are the two fundamental characteristics for binomial distribution. Then you have the normal distribution. So the normal distribution is defined by two parameters, which is the mean of the population and the standard deviation. So that is how you use normal distribution to draw the bell curve. Then you have the probability mass function. So in binomial distribution, the probability mass function uh, gives the probability of each discrete values within the range. So of either the success or the failure. But in a normal distribution, it has a probability density function that provides the likelihood of value. So it is not an exact value, it is a likelihood of values within intervals. So, but it does not give the exact probability of specific values. In binomial distribution, you get the exact probability of specific values, but here in this normal distribution, you will get the values falling within the intervals. Then you have the range of values. So in binomial distribution, the values are discrete and limited to non-negative integers. For example, it could be from 0 to n, where n is the number of trials. Whereas in normal distribution, values are continuous and can theoretically span the entire real number from negative infinity to positive infinity. So that is the entire range of normal distribution. So next, assumptions. So the main assumptions for binomial distribution is that it has a fixed number of independent trials with a constant probability of success. Whereas normal distribution, it follows a continuous, symmetric and bell-shaped distribution, which may not always be the case for real-world data. Then you have the central limit theorem. So again, the assumptions, again the properties regarding the distribution is that as the number of trials increases for binomial distribution, the binomial distribution approaches the normal distribution. Whereas in normal distribution, it itself is based on the central limit theorem, which means that the tails are symmetric and the distribution of sample means a sufficiently large number of independent and identically distributed random variables approach a normal distribution. Then we come into the applications, which is binomial distributions. It is commonly used to model phenomena involving binary outcomes. Again, the most common example is the coin flips, the product effects, and the survey response. Whereas in normal distribution, you can have test scores, the height of the population, the range of blood pressure, the measurement errors, the financial returns. So these are the applications where you can use either of the distributions. So in summary, while the binomial and normal distributions have different characteristics, they are connected to the central limit of theorem. A large number of sample size converts the binomial theorem into a normal distribution. So it basically shows how the binomial distribution approximates the normal distribution as the number of trials increases. So this relationship makes the normal distribution a valuable tool for approximating the behavior of data that may not strictly follow a binomial distribution in large samples. So that is all for today. In case if you have any questions, you can let me know.
That's great. Thank you, Sanjay.
Thank you. Thanks a lot for your time.
Yes, thank you very much.